Good morning. Welcome to the December ACEC Civil 3D user meeting. My name is Brad Hollister, and today I'm going to be talking about our design model standards and some of the proposed changes that we have on the table. Before I do that, just a couple meeting logistical items. If you're having audio troubles, well, you probably can't hear me, but if you're having audio troubles, we have this information on the screen. You can try dialing in. The phone number and the access code are there, and they should also be in the meeting announcement. Also, please be sure to mute your microphone on your PC, and if you dialed in by phone, please mute your phone. And as I go through the presentation today, we will be fielding comments and questions. Please submit those through the chat box. So if you're not familiar with Skype, if you go into the Skype meeting interface here, this instant message button down on the bottom left is where we'd like you to submit your questions and comments. And we will make sure to reserve enough time for the meeting, or we will extend the meeting as necessary to review all the questions and comments we receive. And I can't promise that we'll have our best responses for you depending on the kinds of questions we get, but we'll always circle back and use our blog page or something like that if it's a question that we can't answer today. So before I get started, I have Keith Swinski here with me today, and Keith would like to share with us a Wisconsin DOT Civil 3D update. So Keith, it's all yours.
Thank you, Brad. Okay, hello everyone. My name is Keith Swinski. I'm the WisDOT Civil 3D Implementation Engineer. I just have a couple updates to share before we begin Brad's presentation. First, in January, we will be introducing the Update WisDOT Civil 3D Desktop application. This application will replace the WisDOT Civil 3D Downloader and the WisDOT Civil 3D Updater. Currently, external users use the Downloader and the Updater. Internal WisDOT staff only use the Updater to pull directly from the local server. Moving forward, everyone will use the same system to pull from a single source location, the Civil 3D knowledge base. The current system requires us to replicate the package on each region's local server for internal staff, and then again to the FTP site for our consultants. So the single source system will be a significant improvement. Keeping the files in a single location on the knowledge base has the added benefit of reducing our footprint on the servers, which has been a recent point of emphasis for our IT department. For consultants, this also means that a server deployment option will no longer be included with our tools. It is still possible to create a server deployment, but you'll need to use your company's own processes for that. Before you install the new application in January, it's imperative that you read the provided documentation. As I mentioned earlier, we are planning to release the new Update WisDOT Civil 3D application in January. That update will not include any Civil 3D configuration updates. We want to make sure the transition to the single source location goes as planned before we issue another Civil 3D update. We plan to issue a Civil 3D update shortly after that transition. The second item I have today, we're introducing a new platform that will make it easier to communicate with methods development and your fellow Civil 3D users. Until today, internal WisDOT Civil 3D users could submit ideas to our Civil 3D customization request SharePoint. Unfortunately, external users could not access that page, and the only way to communicate with us was through the support mailbox. Many of you may be familiar with the Autodesk Civil 3D Futures portal. We are bringing that concept local and calling it the WisDOT Civil 3D Futures. WisDOT Civil 3D Futures provides a way for you to submit ideas to methods development. These ideas can include anything related to the WisDOT Civil 3D custom configurations. Some examples include reporting defects, requesting changes to our templates, or requesting new tools such as macros, reports, or subassemblies. WisDOT Civil 3D Futures is open for anyone to view, and it will replace the internal SharePoint page. However, you must request team membership to post your ideas or comments on that page. To sign up, simply email our support mailbox, support.cae@dot.wi.gov. Sign up is free and easy. To find WisDOT Civil 3D Futures, go to trello.com/WisDOT Civil 3D Futures. Or we have a link to the site on our Civil 3D knowledge base. Once you're there, watch the introductory video to learn how to sign up and use the site. I've highlighted the link to the introductory video on the screen. The video is less than 10 minutes long, so it won't take much of your time. As a brief overview, the site contains 3 boards: Submit Ideas, Idea Status, and Tech Preview. The Submit Ideas board is a completely open area for team members to share ideas, make requests, and comment on other ideas and requests that have been submitted. This board is likely where you're going to spend most of your time. In the Submit Ideas board, you will see several lists across the top. These lists represent various topics related to the WisDOT Civil 3D configurations. To add your idea, choose the list that most represents the topic and add a card. We also encourage you to look through the other cards on the Submit Ideas board. You can open any one of the cards and check it out. You can even vote for cards that you like a lot, ideas that you like. You can watch cards if you want to receive notifications on the status of the idea as well. Moving on to the Idea Status Board. The Idea Status Board is used by methods development to communicate whether an idea or request has been adopted. So an idea starts on the Submit Ideas board, and then once it's matured, the idea gets moved to the Idea Status Board by methods development. On the board, you'll see 4 lists: accepted, denied, developed, or development, and deployed. WisDOT Civil 3D Futures members can add comments to these cards and watch the cards, but other than that, all other access is restricted. The accepted list, the ideas on the accepted list are marked for adoption, and methods development will soon begin work on those ideas. The denied list are ideas that will not be adopted and no further action is planned. Methods development will comment on these ideas to explain why. Ideas in the in development list are currently being worked on, and ideas in the deployed list are included in the most recent release of the WisDOT Civil 3D configurations. The third board is the Tech Preview board. The Tech Preview board is a place for methods development to share previews of certain items under development. This board typically contains larger or more long-term development efforts. WisDOT Civil 3D Futures members can add comments to the cards and watch cards on this board. All other access is restricted, so you can't add cards or move cards. The Scoping in Queue list contains items that methods development plans to work on soon. The In Development list contains items that methods development is actively working on. And the Validation and Testing list may contain downloads for you to try out if they are available. Each card might contain videos, documents, or test files for you to review. We encourage you to participate and provide feedback by commenting on the cards on the Tech Preview board. We hope you find WisDOT Civil 3D Futures helpful for communicating with methods development and your fellow Civil 3D users. We encourage everyone to sign up and get started by watching the introductory video. With that, thank you for listening, and I'll pass it back over to Brad for his presentation.
All right, thanks, Keith. I just need a second to get stuff set up here. Okay, on to design model standards. So I did a dry run for this presentation yesterday. It took me about 45 minutes. So that's going to bring us pretty close to 12:30, I got a feeling. But like I said, if we get questions and comments through the chat box, I'll definitely extend this meeting as long as we need to at least review all those questions and provide an initial response. So in my presentation today, there's 4 primary topics that we're going to be hitting on. I want to review the goals for our design model standards update. We have pretty good information available already on our Civil 3D knowledge base about this update and its goals. I would encourage you, if you haven't seen that, to review that. At the end of the presentation, I'll show you how to find that in the Civil 3D knowledge base. I'm also going to be talking about our model feature examples library, what it is, how we see it being used and put into practice. And part of the model features example library is our base level of detail model examples that we'll be producing. I'm going to talk about, how we see level of detail matching into our different project types and how this would be put into practice. It's really those examples that are going to define the standard, and so we have several what we're going to call guiding principles as we go through the decision processes of what kind of detail is necessary on our deliveries. Finally, I'll just review how anybody who's interested in this topic can get involved. So before we get started, I just want to make sure we have a common understanding of some terms that I'll be using throughout the presentation. The first one is surface model. For Wisconsin DOT projects and our design models, the term surface model is a representation of terrain in our contractor data packet. So our proposed work surface models contain a DTM, break lines, and a boundary, and our existing ground surface models just the DTM and boundary. The reason we don't include break lines with our existing ground surface models is, if you've seen our purpose training for design models, you'd be aware that we view our design models as a platform for our contractors to build their models from, and it's the break lines that are most useful for them in those efforts. For existing ground, we don't want our contractors building off of existing ground or changing existing ground. If they've identified any issues with existing ground, we want them to come back to the department and we'll work out those problems together so we don't have break lines with existing ground. The next term, design model, is the proposed work terrain representations in our contractor data packets. So our current delivery requirements have a top and a datum surface model that make up the design model. Datum, if you're not familiar with the term, is the finished earthwork model. And the construction model. The construction model is the model that our contractors are using in their operations. On our projects, our contractors are responsible for construction model development. They may choose to use design model information in the development of construction models, or they could use our design model information as a QC platform to check their construction models. We've seen both of those types of workflows in our project environment. So our design model implementation is not a new effort. We've been at this for a while, and the design model concept itself has evolved over time. We started out with goals for developing and deploying Civil 3D workflows that delivered what we were calling at the time a 100% construction ready surface model. And that was the original design model concept that we started with. So what we were thinking at the time is the design model's purpose in our project workflow was really similar to what a plan is, right? So it's a design intent representation, and we were thinking that it would, function like the plan. So it would be a static document that we produce and design, we deliver to a construction project, and it would be used in a construction project. Now, as we had conversations with the contracting industry about what they needed, what kind of model data they were using, how their operations were being conducted, we saw a variety of complexity and detail in contractors' models, but our goal that we had set was to have 100% construction-ready surface models. So that meant that We wanted to deliver a product that was useful, was able to be used on all of our construction projects by all of our contractors. And we developed the Civil 3D workflow to accomplish that goal. And that's how when we deployed Civil 3D in 2010, that's how we started training people how to use Civil 3D. Early on in our implementation, we had a lot of successes with that concept. But as time went by and we accumulated more and more project experiences, we started to recognize that the design model concept that we started with was maybe not the best, most appropriate use of 3D design practices on our projects. And it wasn't really, a single moment or a single project experience that led us to start thinking that. It was really an accumulation of project experiences over time. Anytime you're starting out something new, you're going to have successes, but you're also going to have, projects that maybe didn't meet all their goals. And we were encountering that. And as we had conversations with project staff that had experienced that, we came to understand that the design model concept that we laid out maybe wasn't the best, most appropriate use of 3D design in our project environment. So if that wasn't the design model for Wisconsin DOT projects, what was or what is, right? We started refining the design model concept. We went through our first iteration of significant change last year in 2017 by reducing the number of surface models that we had. And, now we're implementing something new that we're going to call the Model Features Example Library that's going to further change and evolve the design model concept. And that's what we're going to be talking about today. So with the changes that we're proposing right now, there's 3 issues or goals that we think are achievable with this step. The first one we're calling right size the 3D design effort for our projects. So, we currently have a one-size-fits-all type of standard in the FDM, and we have a full variety, a spectrum of different types of projects in our improvement program. And, even with, the improvement project type classical definitions, the needs of those projects are, variable within a single improvement project type. So, the one-size-all concept that we've been working with is really not as flexible as we need it to be. I'll talk about the second and third goals as we work our way through the presentation, but I want to focus on the right sizing effort first and how the changes that we're proposing we think is going to make significant gains in that goal. So this is more of an overview. I do have a presentation on the Civil 3D knowledge base that goes into much greater detail about how this standard would right size our 3D design efforts. So I'm going to be providing just kind of an overview look at that right now. So really it's all about the design model features example library. And so let's talk about what that is for a second. What it isn't is a library of full project examples. That's not what it's going to be. It's going to be small pieces of project model examples, pieces being commonly found roadway features that we see on our projects. So you'll see on this slide a list of the different types of roadway features that will be included in the design model features example library. This isn't the complete list. We have a larger list than this, and this is going to be a living document, so to speak. So it's something that we can build out over time. We're expecting that we'll hear ideas from people about additional features that we could include in the library. But this is a starting point to just kind of communicate the idea of what we're talking about. These model examples will show people how to represent these different types of features in their design model deliveries. So for each feature within the design model features example library, that's kind of a tough term to keep saying over and over again. We got to come up with a better name for that thing. But for each feature that we have in the library, we're going to have a base level of detail example. That by default will be the minimum delivery requirement for statewide delivery requirement for level of detail in a model feature. And it will be less detailed than I think what people have come to understand expectations are for design models with our initial inception of it with the 100% construction ready surface model concept. Some of the features in the example library will have, in addition to that base level of detail, one or more advanced level of detail examples associated with them. So it depends on the feature, it depends on its purpose and how it's used in construction. The documentation that'll be associated with these examples for the base level of detail drawings, the documentation is going to point out critical elements of that feature and how they're being represented and how that detail should be represented. And we'll do that for the advanced examples as well, but that documentation for the advanced examples is going to also lay out what types of project situations that extra detail of an advanced level of detail would benefit. What kind of project situation would benefit from an advanced level of detail? So that documentation will be included, in the model example library, and it's going to be part of how this is put into practice and part of how we're making everything work here. So the way we see this being put into practice is, again, that base level of detail example is going to be lower detail than I think what a lot of people think of today for a design model expectation for delivery. And we'll have a summary sheet of the full example library concept. And what we see happening is at the project level, so in the region offices, project teams and regions will have an opportunity to develop a design model scope for their project. If they do nothing, if they don't address that, then, well, by default, the delivery requirement would be the base level of detail, right, for the different features that are shown on that project. But they have opportunities to advance level of detail in certain areas of their project where the project situation would benefit from that. And the guidance material that we put out will help people understand when they might want to consider doing that. So the level of detail for a design model scope won't be uniform across a project. It'll be a feature by feature consideration. And it doesn't need to be uniform for a specific feature either. So let's say we have a reconstruct project where we're going to build 3 bridges on it. And these 3 bridges have 6 abutments. Well, the project team might decide that, or the region office team might decide that 5 of those abutments, the base level of detail, design level, is sufficient for that situation. But on that one abutment, maybe we're in a, environmentally sensitive area, or maybe we have a lot of tight constraints and a lot of activity happening, especially with traffic being maintained, whatever the case may be, they can elevate the level of detail for that single abutment. So it's going to be a flexible standard that allows, it's going to lower the baseline on the statewide minimum requirements, and then project teams will be able to elevate detail where and when they think the project will benefit from it. And those decisions will be made at the project level in the region offices where the project needs and situations are best understood. So it's that concept being put into practice that we think is going to provide that flexible design model delivery standard that can be custom fit to a variety of project situations. And we think it's going to take us a long ways towards achieving that goal of right sizing, our design model efforts on our projects. And really what that means to me is finding the best, most appropriate use of 3D design practices on our projects, because that's really what it's all about. Our second goal, improving communication of design model delivery expectations. So we do have design model standards today. They're in the FDM. And we're communicating delivery expectations with articles, with written text and 2D diagrams, right? But the concepts that we're trying to communicate in written text and 2D diagrams are more complex than that. You know, where have we heard that before? That's the whole purpose we're doing 3D design, because, you know, our specifications and our plans, you know, they convey design intent and project concepts, but the 3D deliveries convey even more information, right? Well, the same situation exists with our standards. So we think that providing 3D examples in the form of models is going to help us really improve people's understanding of what delivery expectations are. So, you know, that weak definition of today's standards, you know, just using text and 2D diagrams has been affecting us a couple of different ways. Level of detail uncertainties has certainly been an issue on our projects since we've implemented design model standards. Designers have wondered, you know, have I done enough? Is there enough detail here? I mean, how do you really know, right? And that uncertainty, that problem has been compounded because it's really been a moving target. You know, I think in our user group meetings and over time, we've already drifted away, and, you know, certainly as I've talked to people, I've drifted away from using the term 100% construction ready surface models. In fact, I've deliberately been telling people that's no longer the goal. But we just we haven't until now really had the communication mechanisms to really put those ideas out in a more definitive way. And it's affected our projects in a number of ways. Certainly, you know, engineers, you know, being the types of people that we are, you know, a lot of times we're going to take a conservative approach to that. If we're uncertain how much detail is needed, we're going to invest the extra time to put that extra detail into the design concept to make sure that we've done the job correctly. So there's extra design effort there, and really just the process of wondering, have I done enough? I mean, that slows people down too, and it's affected our projects certainly. So we think that this is going to help in that area. But also people have been wondering as they're designing their projects, how do I represent these different items in the model? What should a retaining wall, how should that be represented in my models? I don't know. Each project, each designer is kind of coming up with their own solutions to that, the way things have been happening so far. And so there's definitely there's an effort impact to that as well. But it's not just that too. It's standardization, right? So just like how standardized plan sheets benefit our projects because we're communicating the same ideas in the same way all the time, standardizing our design model deliveries by, you know, using these feature representations, you know, consistently on all of our projects statewide is going to allow our contractors, the people downstream using these models, to build their workflows in a consistent way out of it. You know, right now they don't really know what they're going to get, and so they're solving their problems each time on each project. But they'll be able to do, you know, more standardized, consistent workflows in their downstream operations of developing their construction models too. So, you know, we're seeing a lot of benefits by improving the definition of the design standard, and, you know, some of these subsequent or lateral benefits I think will be realized as well. Our third goal, the way I've been describing this, is the overextended role of roadway design. It's going to take, excuse me, I have a sinus infection here today, so if I sniffle, I'm sorry. I'm sure it sounds horrible over the audio feed. But it's going to take me just a little bit of time to kind of explain this concept and how we arrived here and how we're thinking about it now and how we're going to correct it. But I'm going to start with a diagram, and what we're looking at here in this diagram, if you go from left to right, it's a progression in the development of the definition of roadway geometry. Okay, and this slide is depicting the classical project flow before we ever did 3D design. So, you know, before we were doing 3D design, we developed roadway design or roadway geometry information in the design process. You know, we start with alignments and profiles. We get as far as cross sections, and that was sufficient in that project flow for communicating design intent. But it wasn't the definition of the full geometry of the roadway, right? You know, there was a lot of missing information that needed to be resolved in the construction of that roadway. And in that classical project flow, how that was occurring was contractor staff would interpret design intent. So I'm going to call that the design intent interpretation gap. Sometimes that interpretation was happening with the assistance of our engineering staff that are out in the field, but primarily it was contractor staff. And the way that worked is it was equipment operators, it was the grade man, sometimes the foreman, utilizing the plan and the information that's in the plan and interpreting it to add the extra detail so that the project could be completed. And one way to think of this is they actually, through that process of interpreting design intent, they would model the design concept, right? Their modeling medium, so to speak, was dirt, and they were using heavy equipment to do it, but that was really what was happening out there. And the equipment operators that were really good at this, and especially before we had AMG, there was a spectrum of skills, right, with equipment operators. In my experiences, the ones that were really good at it could visualize the finished project from plans and from cross sections and from the stakes and the lath that were being put into the ground. So there was a lot of design intent interpretation happening there. And at the beginning of our implementation, we spent a lot of time talking to contractors, and that was always an area of risk for them because they had incomplete information. The more information they had from the design process, the more certainty they felt that they could deliver exactly what the designer was intending to see built. So we were talking with contractors a lot about what kinds of information they find most useful, and we saw a lot of opportunities to close that gap, that design intent interpretation gap. We were just getting familiar with Civil 3D and its potential for roadway design and developing its workflows. And the way we started out in 3D design with Civil 3D back in 2010. This is what that 100% construction ready surface model concept looked like. That same diagram, right? So clearly we expanded the role of roadway design with that initial design model concept. I'm showing a very small design intent interpretation gap there. Even the 100% construction ready surface model concept isn't a full definition of roadway geometry, but it's pretty darn close. But I really could have closed that gap right up to the construction model level there. So it was definitely an expansion of the design's role in the project flow, so to speak. And over time, as we accumulated more and more project experiences, you'll see on the title of this slide, I got a comment there in quotes. I mean, I literally heard those exact words multiple times as I was out talking to people over the years. And, I understand that sentiment, and that's really what our correction here is all about. I didn't go to school for this, and what that means to me is we've extended roadway design beyond the engineering work. And the term that I've been using a lot to kind of describe this is virtual design construction or virtual design. We pushed roadway design into that virtual design construction area with the 100% construction ready model concept. Designers were being asked to add a lot of detail to the design representation in our design models, and it was beyond really the engineering, what I think of as the critical engineering information that we need in doing roadway design and getting into virtually constructing the design concept. So again, as time went by and we gained these experiences, we started to recognize that this concept maybe isn't the best, most appropriate use of 3D design practices on our projects. So this is how we see the model features example library and the way we're going to be able to communicate design delivery expectations. This is the design model concept that we see being put into practice, with the introduction of that example library. What we're looking at doing is strategically retaining the best, most beneficial, most valuable parts of 3D design, and including that in our base level of detail models. So it's going to be more detail than cross sections, the classical cross-section delivery, but it's going to be much less detail than the 100% construction-ready surface model concept. And we're doing that strategically. So we're going to look at this feature by feature, and I'm going to go through, how we judge what important elements of detail should be in the base level and what doesn't belong in the base level. We have some guiding principles about that, and I'll talk about that in a little bit. But that's how we're thinking about it now. We're scaling back, but we want to retain the best, most beneficial, highest return on our design effort types of detail in the base level of detail models. And also because of the spectrum of project needs that we have, we've certainly seen project situations where high level of details definitely benefited the project. And we want to build a standard system and really a Civil 3D implementation with our workflow training, and that allows for elevating detail where and when it's appropriate. And that's so you can see where the advanced level of detail models fall on the scale here. But we're going to do that strategically and selectively as well. And those decisions are going to be made at the project level where the project needs are best understood. It's not going to be a statewide mandate, all projects of this type will do this. That's not the case. It'll happen in the region offices, and the regions will decide where and when they will consider and then put into a design scope advanced levels of detail. So really the proving out of this concept is really hinging on how we define base level of detail, right? Because that's going to set the statewide minimums. And we've developed some concepts, I'm going to call them guiding principles that are going to help us through these decisions. These aren't absolutes, right? So these are just guiding principles, but we're balancing that against other factors too. Certainly we're not going to have a blind eye to design impact, design process impact. So we're going to balance, construction project need and other factors in this, but these principles are going to help us in the decision-making process, and I think that'll start to make more sense as I walk through these a little bit. So the first one, I already talked about this quite a bit. We want to reduce detail from where we were at before, the 100% construction-ready surface model concept, but we want to retain the high-value detail. So this next slide here, we'll soon be releasing this. This is going to be our first base level of detail model example, and this is a Sill abutment. It's the top surface for a Sill abutment. And when you look at this, what you're seeing, the orange line work, maybe you can't even tell that's line work because of the scale that we're looking at this at, but that's corridor frequencies. And then the green planar areas that you're seeing, that's the top surface model. And so you can see looking at this that there's definitely areas of high detail, and I'm going to be talking through some of those and why those areas are high level of detail as we progress here. But you can also see areas that we have lesser detail in the design model, right? You can see those frequencies are spaced out quite a bit in other areas where we don't feel the detail is critical. And then probably what really jumps out at you, which is really, significantly different from what I think the way most people would have understood the 100% construction-ready surface model concept, is we have gaping holes within the grading footprint of this project. So you can see, I don't know, does my cursor show up as I move it around? Okay. So you can see, in the earthwork cone around this abutment, we're not resolving to a high level. We're not resolving at all the geometry of how that earthwork cone wraps around from the slope paving to the wing wall. Certainly, it's going to be resolved at some point in the project flow, but it's not critical. And we're not going to require that in our base level of detail design model examples, for abutment design or for the grading design around abutments. So, clearly this is a reduced detail concept from what we were working with before. Another guiding principle. We want to require the detail that has high communication value of engineering design concepts. And we want to include that in our base level of detail requirements. That Sill abutment example has one of those that's a pretty good representation of that concept. So you can see here, circled in blue, what we're showing there is, I'm going to call that a clear zone transition, okay? So if you were here in the room with me, you could see my hands working, but what's happening there is coming off the finished shoulder on that roadway that goes underneath the bridge, just off that finished shoulder, the design is going to come up at a 3-to-1 slope. And then when it gets to the clear zone limit, it's going to go up at a variable slope, no more than 2-to-1. That's going to be the max slope for this design, all the way up to the abutment, right? But it's going to be somewhat variable because we're connecting between the abutment and the roadway underneath, and so it's not going to be a consistent slope. That clear zone area from the roadway underneath needs to transition where it's starting at the shoulder and going up at a 3-to-1. It needs to transition slowly down to a full ditch section as it works its way away from the bridge area. So as it does that, there's geometric rules. I mean, everybody's familiar with our design standards, and there's geometric rules associated with that transition, right? We're concerned about things like traversability, so that errant vehicles can pass through these areas without, well, safely, let's just put it that way. And we have other geometric rules there as well. This one is kind of variable depending on the roadway type, but there's longitudinal slope gradient maximums within the clear zone as well. And so, this one I'm kind of making some assumptions here. I'm assuming this is like a rural high-speed highway, 2-lane highway. So, the appropriate maximum longitudinal slope within the clear zone area there would be a 10-to-1 slope. And so that's what we're showing here, is we're showing this clear zone from up at a 2-to-1 transitioning at a 10-to-1 slope down to where the clear zone elevation would be in a ditch section. And then we have some drainage to consider. So we have a drainage swale coming from just off the edge of the shoulder that needs to transition down to, where probably a culvert pipe is picking it up, or if we're, depending on which way the water's going, just down to the ditch and flowing away. That's a pretty complex design solution. And we have, it's an important one, right? It's a safety thing. And we understand the design standards as designers. Cross-section delivery alone really didn't communicate all the information that would guarantee that this would be built correctly every time. And that design intent interpretation gap that we talked about with the traditional project flow, we were relying on that to make sure that this was built correctly. But with 3D design, this is where we're trying to retain the highest value items here. And the value here isn't necessarily saving money. It's ensuring that our engineering principles are being adhered to, in the construction of this project. And this is an opportunity to use 3D design to do just that. So we're going to require, with our design deliveries, in the base level of detail, so that's going to be the statewide minimum, we're going to require people show that clear zone transition as you're coming off of slope paving. And it's going to be designed in detail as we're showing in this example. And then, one of the nice things about this is people don't have to wonder how to do that, because we have the example right here, the Civil 3D design data that's behind it, the corridors, the targeting that we use will all be associated and available in that model example library so people can see how we did it. We're not going to say that the model example library is the source of workflow information. our Civil 3D training is always going to be the best source of our workflow implementation. We're not going to keep the model example library current with the best workflow concepts that we have out there with the, the changing Civil 3D tools and everything else. The intent of the example library is to show what the finished product needs to be. But we're going to provide the Civil 3D data so at least people know exactly how it could be done. And then our Civil 3D training is going to put out our best ideas in how to do it overall. But there's going to be coordination. Our training over time will look at these delivery requirements, and it'll help people achieve them. Another guiding principle in developing our base level of detail model examples is that we want to require the detail that's going to benefit the construction project, but we want to option the detail that'll benefit design. And that kind of makes sense, right? Because as designers, we have design delivery budgets, right? And timelines, and sometimes we're feeling delivery pressure to complete our work. And if a detail element isn't going to benefit my design work, I may not include it in my design delivery. But if it's going to benefit the design process, I'm much more likely to do that, or at least I can make an informed decision because I know my design process best. I know my design situation, and I can decide, I can choose whether or not I want to invest and put that extra detail into my work because I'm the one that's going to benefit. So that's where we want to option that. But if it's not really benefiting design, or maybe it's costing more effort in design, but it benefits the project as a whole because of the construction project benefits, we're going to require that. Now, again, these are principles, general ideas in the decision-making process, right? We're not just doing this in the absolute sense. So there's other factors that we weigh into that, and obviously the impact on the design process is something that we need to weigh in, right? We don't want to spend, 5,000 hours in design to produce something that's going to save us $5,000 on a construction project. I mean, that's obviously extremes there, but we're factoring in other things too. It's not an absolute rule that we're dealing with here, but it's a concept that's helping us make these decisions. So our Sill abutment example has a good example. Now this would be one that benefits the construction project. And you can see here we're showing a high level of detail of the design concept in the slope paving. And the reason for that is a lot of times, well, I'm going to say a lot of times, sometimes on our projects we'll build the bridge before the roadway grading is completed, or even substantially completed. Sometimes we'll let a project in the fall, and we can build bridges in the winter, but we can't do earthwork in the winter. So we'll do just enough earthwork in the winter to support the substructure units, and we'll build that bridge through the winter. But when they do that, they're going to want to capture the slope paving area and make sure that they construct that correctly too, because what will happen is after those abutments are built, they're going to set girders. And we better have that slope paving geometry figured out exactly right and consistent with the final design. They can't do that in construction because they haven't done the rest of the grading yet. They have to rely on the design information and whatever modeling they did on their side, maybe catching some inconsistencies if any existed in the design concept. But it's really important to get that area built correctly, because once the girders go on, heavy equipment can't get in there anymore. It's wheelbarrow time if we got to make any changes to that area. So that's a serious inconvenience, let's say, if we later come to find out as we're building the roadway underneath that the geometry isn't working out here, that the slopes aren't coming together the way they need to. And these are things that have happened on projects in the past. And in my personal project experiences, I've seen these things happen. So this is another example of where 3D design can really benefit a project. Here are the benefits on the construction project, and it's really in the form of risk mitigation, right? And really, the design effort isn't bad here at all. So, I mean, if you think about it for a second, the clear zone, that 3D line that's representing the clear zone along the bottom of the slope paving, that's just a function of the alignment and the profile and, the cross-sectional geometry that we're putting in our assembly to resolve that clear zone line. And then we know exactly where we need to be at the abutment. So it's really just targeting between those two things. It's really low level of effort on the design side, but really significant construction project benefits in the form of risk mitigation. Now I don't have an example to show you here that depicts the other kind, but I'm going to jump back to an earlier slide. I said we want to option detail that benefits design, right? We want designers to decide then if the benefits on the design side. And the example that I'll choose to convey that idea is curb ramps. So curb ramp models aren't used in construction. That construction operation, at least in today's world, is not model based, not on our projects anyway. And our required deliverables for curb ramp design is a construction detail drawing. And that's appropriate considering the construction operations, the way things are happening today. Some of our designers would tell you that the most effective, efficient way to develop ADA compliant curb ramp design concept, or pedestrian facilities design concept, because it's more than just a curb ramp, right? Some of our designers would tell you that a model-based workflow is the most effective way to do that. And we have Civil 3D training that teaches people how to do that. And then with, the intelligent automated labeling that we get in Civil 3D, it's a really efficient pass-through from the model that they may develop using a model-based design process to the plan sheet. With these labels, we can produce construction detail drawings, and the QC is pretty reasonable too, because we have direct linkages, and we can see the design concept with the model. We have direct linkages to the plan content, the elevations. Now, other designers that are designing our projects would tell you that their preference would be to use a more traditional method of doing this type of design work. So, that's going to involve, establishing elevation points and calculating gradients and, pushing things out in directions and figuring out if things are matching in well and going through iterations and, really developing the design concept that way, really a traditional method, almost a site design method type of approach, but, on a micro scale, Other designers will tell you that that's their preferred way of doing that design work. And, then they're going to take that information, they'll end up with the required deliverable, which again, that's a construction detail drawing. So by optioning curb ramp models and developing workflows that show people how to do that, we're allowing and showing people efficient ways to do the model-based processes, if that's their preference, but we're not requiring it on people. And people that would prefer to do the traditional method, that's perfectly allowable as well. So our base level of detail examples will not show curb ramp representations. The design model concept will not need to represent that. And really that's consistent with our initial implementation. That's just it's an indication of that weak communication method in the FDM, right? And the model example library is going to help us clean that up a little bit. But since day one, that's been the policy. It's always been optional. We just haven't had a good way of communicating that to people, and so there's been misunderstandings out there and really frustrations because of it. Some people that would have rather done the traditional method have been feeling like they've been forced to do curb ramp modeling, but the FDM has always said it was an optional item. It didn't need to be represented in the design model, and that was our thinking behind that. So it's consistent with today's standard as well. Okay, the final guiding principle that I'm going to talk about today is we want to make sure that we're pushing the design concept far enough along to ensure geometric constructability, and our Sill abutment example has one of those too. So the blue arrows that you see there, if we develop the design to this level of detail, and if our design concept is calling for a maximum of a 2-to-1 slope around this abutment, we can check that by measuring from the corner of the earthwork, well, that platform that comes off the front face, down to the clear zone. And when we release this draft example, if you take that measurement, you're actually going to find that even though the slope paving doesn't exceed a 2-to-1 slope, those areas where those arrows are, it will. So this can happen. It's important to do those kinds of constructability checks. Now, if that was a real design situation, what would you do? You'd just slide that clear zone transition further to the right, right? That's going to flatten out that slope. That's going to allow, and you do that until you achieved your 2-to-1 slope all the way around. And you can check that as you go with those quick measurements. But we don't have to resolve all the converging, geometric elements to, their exact correctness in design to do these constructability checks. We can do it just by measuring in Civil 3D. So, where we see these opportunities to ensure geometric constructibility, we're going to factor that into our considerations, because really that's where some of our project issues have popped up in the past pre-3D design, with the cross-section delivery, the traditional type of project flow. And so that's one of the benefits of 3D design, is being able to ensure geometric constructibility. And so we're going to look for those opportunities, and we're going to factor that in as well. So our process, how are we going about this? We're going to be developing model feature examples incrementally, right? We're going to pump these things out. We'll release them incrementally as they're ready to be released. It's one part developing the model itself and the geometry, and there's some thought behind that, obviously, as you're probably understanding through our presentation today. But then there's the documentation associated with it too. We're going to release those incrementally, and they'll be in what we'll call a draft status. And we're hoping to get the industry's attention here, both the roadway design community and the construction industry, really any stakeholders that are interested in this process at all and want to get involved. We want to make sure that opportunity is available to them. And as we go through that process of commenting and questions and our responses to them, these examples will eventually graduate from draft to what we're calling a guidance status. And guidance status is going to allow us to achieve the benefits, all the benefits that I talked about today. The design model concept that I've been talking about, the model features example library implementation, it all fits into today's FDM standards. We don't need to change our design model standards in the FDM to implement this. What we're really doing is we're better defining it. We're creating a much stronger definition or communication of what design delivery expectations are. But the delivery requirements themselves in the FDM, we'll have to make sure everything's consistent, but in a major sense, in a fundamental sense, everything that we're talking about today fits within today's FDM standards. So when these model examples are in a guidance status, we'll be able to realize the benefits of them. So guidance status means it's ready to be put into practice. It's been vetted out. We've gone through the commenting. We're ready to put this thing into practice. And the benefit of having them in a guidance status for an undetermined period of time is, once we put these things into practice, we're going to start getting project experiences again, and we're going to start accumulating those experiences and getting feedback on how all this is working. We can be much more nimble in any needed changes, any changes that we see, that we identify need to happen to this concept while it's in guidance status. Making changes to FDM standards, there's a process associated with this. But while they're in guidance status, we'll be able to be more nimble and react to those change needs much more quickly. Our goal of achieving a standards status for them remains, but we're not going to set a timetable for that. We're going to really put this into practice and see how things are working, and we'll leave that as a goal for now, but we're not going to set a timetable for it. So, how can you get involved? Last slide too, so what did I say, 45 minutes? Pretty close. There's different ways that you can get involved. So we have information out there today in our training website, the Civil 3D knowledge base. You have a link for it there on this slide. on the home page for the Civil 3D Knowledge Base, there's a digital data section, and within that digital data section, there's a design model standards subsection. There's a design model standards blog page. That's where we're going to be sharing our responses and reactions to questions that we're receiving. We're going to be sharing status updates on the blog page. It's going to be kind of an informal way of us, putting out information in a quick sense. We have a design model standards update. There's a little bit more formal information there about the standards concept itself, and we do have information out there for people to review today. And then our model example library itself is going to be hosted right here in this subsection of the Civil 3D Knowledge Base as well. Now, in addition, at the beginning of our user meeting today, we heard Keith talking about Trello as a communications mechanism. And we're going to be building a similar Trello site for design model standards. So it's going to be separate from the Civil 3D Futures site that Keith has already established. But it's going to work similarly. And it's, to be focused on design model standards stuff. And we're going to establish that. And it's going to be a way for us to receive your comments and your ideas. Now, part of just the way that's going to work, the way Trello works, is you're going to have a user account, and when you post information, that your username is going to be associated with that. And we realize that might not be in everybody's comfort zone, so to speak, that some people might want to just ask a question but not do it publicly and in front of everybody else, and we're sensitive to that too. So we'll continue allowing or really encouraging, if people want to say something but not, out on the Trello site, send us an email, give us a phone call, whatever the case may be. We'll engage in that conversation. And, depending on, the kind of information or questions that we get that way, we might ask you if it would be okay if we take your question and we put it out on the Trello site, but we'll put it out there, anonymously, maybe say from a anonymous roadway designer sent us this question and here's our response to that question. But, so that channel remains open too. So if you don't want to use the Trello page, I think probably the only reason you might not want to use it is, because of the public nature of it. So if that's the case, you can still contact us directly and we would entertain that too. Most of our responses will not be through Trello though. Our responses will be, primarily through the Civil 3D Knowledge Base and, the structure that we're creating there as well. Whew. So there we are. That's my presentation today. Thank you for your interest and for listening in. And I'm going to open up the Skype window here and see if we have any questions. Okay, so I'm going to stay here for another minute or two. I didn't receive any so far, but if you have any late ones in, we got about another minute or two for you to submit it. Otherwise, again, I'd just like to thank everybody for their interest in listening in today. And, I'd like to encourage you to, if you haven't already, take a look at the Civil 3D Knowledge Base at the digital data section that we have out there. We have other good information there as well. It's not just about this current design model standards, but we have information about design models in general. Our perception, what we've gotten through our interactions with contractors in, how design models are being used on our projects, and not just contractors, but, what we're hearing from our own staff and the design community as well. So we have information about the purpose of design models and different elements of design models, the purpose of contractor data packets. So, there's really a lot of good information out there. And if you haven't seen that yet or looked at it, I'd encourage you to look at that as well. Oh, I was just going to close things down, so it snuck one in on me. So the question is, are these changes going to be communicated to contractors as well? Most seem to still expect 100% design models. That's a great question, Sarah. Thank you. Yes. So we've had opportunities. So that the different channels that I've had to talk to contractors have been we've had working with WEMA and WTBA, we've had a representative group from the contracting industry that has volunteered to, their time to spend with us, and we've had several rounds of engagement with them. We have not put this to that group directly yet, but we do intend on doing that. We also, we have a standing place on our grading GLS committee, the Grading, Landscaping, and Sewer Committee, which is made up of, that group of contractors plus department personnel, talking about policy issues and stuff like that. I have a standing place on their agenda, which is an opportunity for that industry to provide comment to us as well. And also, I'm going to be directing our contractors, if they're willing to also use those same communication methods, through Trello and whatnot. So if they want to provide input on a specific model example, they don't have to wait until we have another meeting at their office. They don't have to wait till the next time they get to talk to us. They can go that route, and of course we'll have the same other opportunities. Contractors might not want to share their thoughts or their trade secrets, so to speak, openly on Trello as well, and so we're going to be sensitive to that too. So they can informally reach out to us by phone or by email as well. But certainly we're hoping to get more than just the roadway design community input on this. We've found several terrific partners, throughout the history of this entire effort, dating back all the way to 2007. Definitely from the construction contracting community. But as our implementation progressed, we've found other partners out there as well. Equipment vendors that are supporting our contractors in their model-based operations. We found some really good partners from the equipment vendor industry, providing input, and we're going to be trying to get their attention in these latest developments and get their input as well. They've been a really valuable partner to us as well, because when we talk to a contractor, contractors are doing a lot of things differently from each other, and they do that for a reason. There's competition, right? And they each build up their own processes and their workflows, and they've invested a lot into that, training of their staff. Their staff are used to doing the same thing the same way time and time again, and so there's efficiencies associated with that. But when we talk to individual contractors, we really just get that one perspective, right? And they're doing these things differently, absolutely differently from one contractor to the next. When we talk to the equipment vendors, we get a broader view of the contracting industry, because they're working with a wide range of contractors and different solutions that they've put in place. So we found that group to be a really, really valuable group, and we want to engage there too. And then there's the software development industry as well. So, we have Civil 3D, and we use that as a design tool, but there's software specific to contractor workflows and contractor needs that are out there as well. And we've engaged with that software development community, the ones that are developing the softwares that our contractors are using, helping them, starting with them, showing them the design information that we're sharing, and then, talking with them how that information could be beneficial in their software tools too. So we definitely are looking to engage with the construction industry, and we're hoping for that same level of engagement that we've really benefited from over the last 10 years with them on this effort. So thank you for that question, Sarah. That was a great question. And I didn't see any more roll in, so I'm going to call it a day. And, one more final thank you. Thanks for bearing with us today, and thank you for your interest. And really, I hope to see, your involvement as we go forward in really defining this standard, and, really, once again, trying to establish the best, most appropriate use of 3D design practices on our projects. So thanks.